Hello, pre-calculus students. Today we're going to learn how to graph sine and cosine functions on the xy plane. So let's take a look. Y equals the sine of x. If you recall from our previous instruction, we remember if you're going along the unit circle starting at 0 degrees going to 90 degrees, or 0 to pi over 2 radians, your sine value, your y value on the unit circle goes from 0 up to 1. So you can see here's 0 radians, here's pi radians, this is pi over 2. Sine's going up from 0 to 1. Now, so here we go, 0 to pi over 2, we went from 0 up to 1. Now from pi over 2 to pi, see, we're doing, pi over 2 to pi going in your direction. We go from 1 back down to 0. And from pi to 3 pi over 2, we go from 0 to -1. And then from 3 pi over 2 to 2 pi, we go from -1 back up to 0. So you have this one peak and one valley. That's one period of a sine function. You'll notice the y-intercept is 0. The x-intercepts are all the integer values of pi. So we say it's pi k, where k is assumed to be an integer. The maximum value of the sine function is 1, and it occurs at pi over 2 and every 2 pi before and after that. And the minimum value is -1, and it occurs at 3 pi over 2 and every 2 pi before and after that. Now, a period, you can't just go from, x-intercept to x-intercept, because this isn't a period. To find the length of period, you have to go from peak to peak or valley to valley. And you'll see that it's 2 pi either way. A cosine curve, remember on the unit circle, over here at 0, the cosine is at 1, because that's your x value. And as you go fourth of the way through the circle, it goes to 0, 1, 0, or I'm sorry, 0. Let's try it again. 1 to 0 to -1 to 0, back up to 1. So it's 1 to 0 at pi over 2 or 90 degrees. -1 at pi or 180 degrees. Back to 0 and up to 1. And here's information on the intercepts. All right, sorry about that. Took a pause because I'd forgotten to load a picture. So what I'm going to do now is, well, these are the sine and cosine curves. How do you remember which one's which? Well, you should be able to remember, but if you need you will eventually. But if you need a quick jog for your memory right now, a little quick fix to help you remember it, let me show you this picture. Get it? It's a stop sign. Dad joke. I thought it was hilarious. But anyway, you can see that it starts at 0, goes up to 1. Well, one way we describe it is it starts at the midline, goes up to the max, then the midline, then the min, and then the midline again after 2 pi. And that should relate to this sine curve that we see here. So that's how you can remember a sine curve and a cosine curve really quickly until these are in your head so fluently that you don't need that trick anymore. Now, this book uses a times sine or cosine of bx minus c plus d. Other books use bx plus c. That gets all my formulas mixed up. So I'm actually going to show you a different way to remember some things. I think it'll be helpful. But here's our function. And when you put an a outside the function, what is it always done with functions? Well, it stretches the graph vertically. Or if also if a is negative, it reflects it over the x-axis. So there's nothing new there. And in class, we'll do some examples of that on Desmos. So that a value that stretches our graph stretches or squishes our graph vertically, the absolute value of that is the amplitude of the function. So amplitude is never negative. Please make a note of that, highlight it, star it, use different colors, whatever. Because I'm going to give you functions, and I'm going to ask you the amplitude, and a is going to be negative, and you're going to give me a negative number. It happens all the time. Make a note of it. Amplitude is just a distance, which is neither positive or it's never negative. So the amplitude of a function is the distance from the midline to the peak. So you could take the peak value of 5 minus the midline value of 0. This function has an amplitude of 5. Or you could go midline minus the minimum. 0 minus negative 5 is 5. Or you could take the maximum minus the minimum. 5 minus negative 5 is 10. Divided by 2 is 5. So this function, this is y equals 5 times the sine of x. So all we did is we stretched it 5 times vertically, and the amplitude is 5. If a is negative 5, y equals negative 5 sine of x, all it's going to do is take this graph and flip it over the x-axis, but the amplitude is still 5 because the absolute value of negative 5 is 5. Still, the peak is 5, the midline is 0. Still, the midline is 0, the minimum is negative 5. And still, 5 minus negative 5 is 10. So no matter what, the amplitude of this function is 5, not negative 5. Got a new word for you? Sinusoidal. Sinusoidals are curves that just do this. Keep going up and down, like the bobblehead. So the period, we've already talked about that, is how long does it take for the graph, or how long in the x direction does it take to go from peak to peak, valley to valley, or you can just look at, okay, that's one complete cycle. That's the period of the function. How long does it normally take to go through one cycle of sine or cosine? 2 pi, or 360 degrees. But what if we stick a value in here instead of the sine of x? Now it's the sine of 2x. The way I like to think of it is, well, think of it, what did we always do with functions when we multiplied, our x by a number? That either compressed or stretched our graph horizontally. And I think of it as I'm going through the x's twice as fast, so the period's going to be half as long. If I drive from here to Reno at a normal speed, it takes me, from my house, 2 hours. If I double my speed, it'll only take half as long to get to accomplish the entire mission of going to Reno. So if it's y equals sine of 3x, I'm going through my x's 3 times as fast. So the period will only be 1/3 as long. So if we have y equals a times the sine or cosine of bx, the amplitude is the absolute value of a, and the period is 2 pi over b. And we can show that on Desmos. We'll do a few examples. On paper, it'll look like this. Here's y equals the 2 times the sine of 4x. So instantly I look at the period. 2 pi over 4 is pi over 2. So I drew a ticky mark at pi over 2. Then I cut it in half, which is pi over 4. Cut that in half, which is pi over 8. This isn't pi over 3 in here, folks. The halfway between pi over 4 and pi over 2 is not pi over 3. So this is 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. So cut this in half and then half again, and then you can label your marks. Because remember, on that sine and cosine curve, everything happens in 1/4 of a period. Each quadrant, you get either a maximum, a minimum, or a midline on that unit circle. All right, and now I just do it's a sine curve. It's not negative, so I draw my sine curve. And then I notice the amplitude is 2, so I put a 2 up here, and I mark this minimum value as -2 down here. So I did the x ticky marks first, then I graphed the sine curve, then I graphed the y ticky marks. That just made it quicker and easier for me to graph this function. Three times the cosine of 3x, the period is 2 pi over 3, so I make a period of 2 pi over 3. Cut it in 2, I get pi over 3. Cut that in 2, I get pi over 6. So here's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So I've now divvied up the x-axis. Not a little sloppy here. Should do that. Now it's a cosine curve. Cosine starts at that peak. So, you know, one quadrant or 1/4 of the interval, 2/4 of the interval, 3/4 of the interval, one complete interval or one complete period of the cosine. And then the amplitude is 3, so I go up to 3 and down to -3, and I mark those on the y-axis. If I have 2 times the cosine of theta over 2, usually with angles we use theta, so we're going to use theta and x interchangeably. This is my theta axis and y. 2 pi over 1/2 is 4 pi. So I go up 4 pi, 2 pi, 1 pi, and that's going to be 3 pi. It's a cosine function, so it starts at a peak. 1, 2, 3, 4/4 of the period. And then I label the 2 and the -2. So far today, we've only learned about 2 new functions, sine and cosine. And what are we going to do to can't think of the word right now, transform them? Well, we're going to stretch, reflect, and translate. So we've already stretched stretched vertically with that a value, and we've stretched or compressed horizontally with that b value. Now we need to, and reflect would obviously be, making that a value negative would reflect it over the x-axis, and that b value, we're not going to ever put, of course you could reflect it around the y-axis by making that b negative. We're not going to do that. We're going to stick with positive values of b. So now we have to translate horizontally and vertically. So let's go back up here. Y equals a times the sine or cosine of bx minus c plus d. We already know that the amplitude is the absolute value of a, and the period of the function is 2 pi over b, b being the number in front of x. Now, if you remember bx minus c, if you remember that instead of bx plus c, which some books use, well, if you set that equal to 2 pi and solve for x, you get this. And this is doesn't mean anything mathematically, it's just a mnemonic. This 2 pi over b ends up being your period, and c over b ends up being what we now call a phase shift in trigonometry. It's really just a horizontal translation. However, I'm going to show you a different way so that you don't have to remember bx minus c as opposed to bx plus c. You don't have to remember this. So this is the official math way that I'm showing you. I'm going to show you a different cool way. And this takes advantage of what you've already learned in the past about how you translate functions. You translate functions horizontally by replacing x with x minus h. So let's factor a b out of both of these terms and we get this. Well, this b is just normally if in any function, if we put a b in there and multiplied our x by it, that's going to stretch or compress it horizontally. And that's what 2 pi over b does. It tells us the period, which will either stretch if b is between 0 and 1, or it will compress if b is greater than 1. And now we have an x minus a number, c over b. And we know what this does. If you replace x with x minus a constant, you translate your function to the right. So if c over b is positive, you translate it to the right, and if c over b is negative, you translate it to the left. In other words, if this was x plus c over b, then that would be the same as x minus negative c over b. You get the idea. So I'm going to recommend that you just factor a b out of these each time, and then you don't have to remember anything new. You don't have to remember, well, if it's negative c over b, no, you already know. X minus h translates your function h units to the right. So in class, we're going to graph these 3 functions on Desmos, and you'll see what each of these letters does. We're going to put in a b value and then a c value, and then you'll watch it translate pi over 4 to the right. So just write these 3 functions down now. We'll graph them in class. I also have another function for you. We're going to graph this one by hand. So just make a note of this now. Leave yourself some room. Y equals 2 times the cosine of the quantity 4x plus pi over 3. Write that down. Leave yourself plenty of room to graph by hand. Also, one more, y equals 3 times the cosine of the quantity 2x plus pi over 2. Leave yourself plenty of room to graph that. We'll graph it by hand. We'll check it in Desmos. And then that will give us, those A, B, and C values will give us our stretch, reflect, and horizontal translate. Now all we have to do is add a constant at the end, and that was that D value. Here it is from this slide. That D value will vertically translate our graph. Well, that's it for this lesson. Some new stuff here, I get that, but you're going to be okay. Trust me on this. It's not, I know it's new, but you will understand it very soon. All right, have a great day.